My name is Ali Hashimi. I'm Director of Technology for Deloitte. I lead the Artificial Intelligence and Emerging Tech practice for the consulting firm. Prior to Deloitte, I was an MIT Media Lab fellow. I've also done fellowship with Harvard Law School. So I have an interesting mix of consulting as well academic experience. Currently, I'm engaged in running a large-scale production-grade blockchain implementation in the region, which is one of its kind. And there are very few, actually, if you come to think about it. Right now in the public sector, there are 5 or 6 big production-grade implementations in the world, 2 or 3 in Estonia, 1 in Finland, and then if you count R3, for example, in UK, like you can actually count them on fingers. So the implementation that we're doing is large-scale production-grade in the region. So we've learned a lot from that experience as well. So I want to start with actually this concept of why blockchain is so important. Actually, I'm going to focus on the challenges and obstacles, but really, like the key thing here is like this is really a very disruptive technology, and if you come to think about it, it is very radical in terms of what it is capable of doing. And most of the times I've noticed that people focus on the ledger part of it or the immutability part of it, but there is more to it actually. So I want to start with this analogy, which is actually rhizome versus tree. So what is a rhizome actually? Rhizome is actually an underground stem which basically grows continuously, and the other thing is that at any point on the rhizome can connect to any other point. So unlike the trees which are hierarchical and there are degrees of separation between the nodes, in a rhizome you can have any point connected to any other point. So rhizome is actually a very interesting kind of analogy for blockchain. And why is that? Because really, if you have that, it delimits the space for you and really enriches the space. So it's very different from a tree-like structure, a hierarchical structure, a central structure, which essentially impedes growth. So this is an interesting analogy to think about. The other thing, the other analogy that I want to talk about is that of spot markets or markets. So I'm going to actually quote this paper. It's a groundbreaking paper by Friedrich Hayek, who was an economist and market theorist. And he wrote this paper called Use of Knowledge in Society, and which has actually influenced people like Jimmy Wales from Wikipedia. And what he was saying was he actually argued against the case of central pricing board. So he said that a central pricing board can never be as efficient as actually a decentralized system. And the reason for that was that if you're actually in a market, as a central authority, they will only possess partial information, not the complete information. So when you actually have a market which is decentralized, it is organic and it's delimited. And the other thing is that it adapts more efficiently to price fluctuations. That's why if you actually take blockchain, if you start thinking about blockchain in those terms, you will see how powerful this concept is actually, because it's really like thinking about it as a spot market, and because we have limited ourselves to some fundamental, like very few use cases in this space. It's important to actually realize that how it is actually a new way of value creation. Now, in that particular paper, there is an interesting quote that he actually put in, which was, I'm going to basically read it for you. If we possess all the relevant information, if we can start out from given system of preferences, and if we command complete knowledge of available means, the problem which remains is purely one of logic. So it's a very important quote, and I've actually highlighted key areas here. So all the relevant information, complete knowledge of available means, and logic. So if you think about blockchain, and when you put something on the chain, it's open, accessible, everyone has it. Really, how is this going to actually behave? It's going to be governed through logic or mathematics, actually. So that's why when we talk about blockchain is really governance through technology or mathematics or algorithms. So it's an interesting way to actually conceptualize what Hayek was saying. Now, the other thing to keep in mind is, like Hayek also mentioned, for example, if there's scarcity in the market, it will be much more easier for in a decentralized system to communicate the information rather than in a centralized system, just because of the inefficiencies. So I think this sets the tone for what this blockchain is capable of. The other thing that people are not grasping is that blockchain is a fat protocol. So what is it? What do I mean by that, actually? So if you're building an application nowadays, what you will do is basically you will have a very thin protocol and you do a bulk of your stuff in the application layer. So what does that mean? So if I'm actually a service provider, I'm building something for the customers in a traditional non-blockchain application, what you're seeing right over there, there's a thin protocol layer, but you're putting a lot of effort in that application layer. So really, you're spending a cost and effort on the application layer. In the blockchain, if you actually conceptually understand it, the way it works is that you put a lot of that stuff actually in the protocol layer. So what that does is, once you deploy the technology stack actually, it has done the bulk of work for you. So you can now really focus on the application side. So that's why it is such a radical idea, because once you have actually deployed the stack, now you can just focus on the aspects like what am I actually delivering to the customer. So really, this is something really revolutionary in terms of what it's doing. So the first part is important, like FAT protocol, and how do we get there, we'll look into it. Now, we have discussed like how this is such a disruptive technology. This can actually revolutionize in many ways, but right now, if you look at it, blockchains right now, so the one success story that we have is that of Bitcoin. That's the only success story that we know of. The second one, closest one, is Ethereum, basically. And Ethereum has been 4 years. And if you look at GitHub right now and just go into the blockchain projects that we have, you will find that, interestingly, there are like 80,000 or 90,000 actually projects. Out of those, like every year we add about 10%. And out of that, actually, only 8% succeed, and the longevity of them is about 1.22 years, something like that. So it's an interesting space, because right now technology is evolving, and we are not seeing projects which have longevity. And there are numerous reasons for that. Yesterday, I gave an example of TCP/IP, where I mentioned that when TCP/IP started, we started with a single email in ARPANET. And the next phase was, it was localized to Department of Defense in US. And the third stage was substitution, where the businesses started taking over in that particular protocol. And the fourth stage was transformation. So in the case of blockchain, we are actually getting, we're somewhere in between, for example, the isolated case and the second case that is the localized environment. So we still have to see, it's being, going into the substitution or transformation space. But what are the reasons for that? So let's just focus on that. So typically, when we talk about the problems, we think of in terms of scalability, privacy, perceived costs. So scalability, right now, the transactions per second are somewhere around, for some average transactions would be about 30 transactions per second, which is nowhere near where the financial transaction should be in some of the use cases that are using blockchain. Second is privacy issue. Privacy issue, it's an important issue, because anything you put on blockchain is open and accessible. So it's actually good for some areas, but in some areas it becomes an issue as well. And it's going to drive things in a different manner as well. Now think of a use case where you're actually putting a product on blockchain, and there are multiple competitors out there. When you put your inventory there, your competitor would know actually how much of an inventory you've put in on the blockchain and what the price is. So it is an expensive technology. The other thing is that consensus mechanisms are evolving. We have proof of work, proof of authority, proof of stake, others as well. there is issue with that as well, because there is no, right now, silver bullet which will address the consensus mechanism at this point in time. There's also the issue of trust of technology, which is saying if you blindly put everything on technology, like you're thinking governance in terms of technology, is it really like the right way of approaching it? Or are we actually thinking about, for example, we need to have some additional layer, additional role layer required in governance when we deploy this technology? Then legally binding is another issue. When you deploy these technologies, what is actually legal in one state might not be legal in other nation state, because if it's global in nature, you have to accommodate that. And finally, opposing standards, which I mentioned yesterday as well, that GDPR has interesting provisions like right to forget. So if I'm putting my information on the blockchain, it's immutable. And GDPR would actually not allow that. Why? Because you cannot put any information there which is immutable. That's one. The second thing is there are also provisions in there which say that I should not be, for example, identifiable by any means. There are so very important privacy considerations. So even if you encrypt my privacy, there are ways to actually know who the ID, who that person is, who that entity is. So that becomes a challenge. So these are the main challenges. But if I look into these actually, these can be addressed quickly. So I'll just give you an example for cost. If you really actually are thinking about cost, it is not much actually. So if you're deploying a node, for example, and you have a blockchain already, I'm talking about, let's say you have a blockchain and I want to be part of that blockchain. The cost is on cloud $500 per month. And this is an average cost on the cloud, depending on whether they have the blockchain infrastructure available or not, so the AWS. Now, on-prem cost, if you actually want to break it down on a 48-month cycle, it will be anywhere, it's around the same number as well. And the reason is you can actually break it down. In 4 months, you have to recycle as well. So it's, again, if you look at it, it's not much. It's peanuts for any organization which is doing business in particular in the e-commerce space. So the cost is not an issue, basically. So we're going to focus on important ones. So if you look at all these ones, the most important ones are actually scalability and privacy. And how do we address that? And I will go back or anchor my talk again on the Hayek's talk. When all the relevant information is available, the problem is that of logic. So it's really logic which is going to address these problems, nothing else, basically. That's why when we talk about blockchains, we talk about blockchain is really a mathematical problem that we are trying to address. And that's why you will see in a lot of these mechanisms, consensus mechanisms and others, there's a lot of mathematics involved. Now, when it comes to scalability, if you look at how it's being addressed, I think there are quite a few things that have emerged, basically. So we'll just quickly go through them. So one is this proof of work is evolving into proof of authority and proof of stake, which has given us higher transactions per second, basically. The other thing is that we are starting to employ game theoretic approaches as well, which we'll see on other things. And when it comes to privacy, I think they're addressed in quite a few different manners. Like there are different ways of addressing it. For example, anything that you put in on-chain is publicly available, but you also have access, you have things like off-chain stuff where you can put in stuff which is private, actually. But then it has other issues like how would you address that computationally? So that is addressed already in the infrastructure, but then you have things like zero-knowledge proof and homomorphic encryption and distributed hash tables. These are like different ways of actually addressing that, the problem of privacy and confidentiality on the blockchain. Again, the quote is over there that if you look at these problems are actually will be addressed through logic. So if you look at this blockchain consensus mechanisms, they have evolved. So proof of work, proof of stake, proof of authority, Hyperledger works in a different model. So again, it's in a state of evolution, and it has given us higher transactions per second. So we are going in the right direction, actually. But let's look at how this will actually work. So if you look at the ideal end state is, for example, for us to achieve completely decentralized system. And here, quite a few people were talking about publicly distributed ledgers, but a decentralized system would mean that anyone can actually join the blockchain. That's what decentralization means, and no one has control over it. This is what the ideal end state should be. Now, interim, you can actually have ways of actually addressing issues like, for example, scalability and the stuff by actually introducing an authority node. And it's actually good for public sector. Why? Because you can actually trust one entity initially that can actually address the issue of decision making. Now, the other part is that there are evolving models around it as well. Like right now, if some of the new blockchain technologies that have come up, they have moved into a different direction. Now, first I'll give you an example of permission distributed architecture, which is not really decentralized. So there are actually technologies out there right now, R3 Corda, but really their permission distributed architecture, they're not really fully decentralized. That's something to keep in mind. So if you want to really reap the benefits of what blockchain is, we have to focus on the previous version. So now, what are the emerging trends in this space? So some of the new blockchains that have emerged, what they're doing is that they're actually incentivizing participation. So they're using game theory approaches where they're seeing it as a non-zero-sum game and saying, like, if I'm actually participating in the network, I should be rewarded. The other thing is that so it's again trying to sort of mitigate the issue of selfish or greedy algorithms, essentially, when they are employed for participation. So that's one thing they're employing. The other thing that they're doing is that in these technologies, what they're doing is they're coming up with consortium kind of approach where the nodes get actually promoted to an authority level on some probabilistic means, and that allows us for better decision-making on the protocol. So again, game theory is going to play a huge role in this particular space. So next, I want to talk about, so privacy part, and privacy part is on blockchain is actually addressed in, this is a typical blockchain node. So this is already part of the infrastructure that you all have. So off-chain storage allows you to address some of the things. The other part is that there are new solutions emerging, which are basically like trying to solve the problem of privacy by using distributed hash tables. So this is an example that from Enigma, for example, in which you will never have complete information on the blockchain. So basically, you will have some of the information on the public side, and only someone who has access to Enigma, which is a construct basically on this blockchain technology, will have full information over there. So the way I want to actually close this is that right now, you will have emerging approaches in technology which will try to address these issues of scalability and privacy through various mathematical means. And that's going to be the trend forward. The other thing is, increasingly, what will happen is we may have to think about things like making things more open. So blockchains survive in an open world, actually. So apart from privacy considerations, like, for example, citizen data and other data, we may have to think about how markets operate in a radically different manner. So where, for example, asymmetric information is not the norm, actually. You'll really think about, if I'm going and doing spot market kind of structure on blockchain, what will happen is that you have to behave in a different manner. And how that will actually come about is actually not through actually asymmetry of information, but actually coming up with the better algorithm, actually. So it will be ultimately algorithms or mathematics governing this space. I think in the interest of, like, I had 15 minutes to talk about it. If you have any questions, I'm here to answer.